Chapter 2 is on linear equations and functions. Section 2.1 represents relations and functions. Here is a vocabulary list for what you will need for Section 2.1. Relation, it's a mapping or pairing of input values with output values. A domain is a set of input values. The range is a set of output values. A function has in which each input has exactly one output. An equation in two variables is just an equation that has two different variables represented. And a linear function is a function that can be written in the form y equals mx plus b. A relation can be represented by ordered pairs, tables, graphs, and mapping diagrams. You are familiar, I'm sure, with ordered pairs, tables, and graphs, and maybe not so familiar with mapping diagrams. We want to talk about domain and range. First of all, what is a domain? A domain is a set of inputs. So for ordered pairs, the set of inputs are the x values, which are circled here, -2, 0, and 3. You will notice that -2 is listed twice, but we say what is a domain and list it only once. So the domain is -2, 0, 3. In the table, it is a set of x values. In the graph, you can see here that it is the x values. If we have this ordered pair, -2, 2, you can see that x, -2. If we have here -2, -2, and then we have 0, 1, and then finally we have 3, 1. I'm underlining the input values, that is your domain. And on a mapping diagram, the set of inputs, what it's being mapped from. The range is the set of output values. So on the ordered pair, it is 2, -2, and notice 1 is listed twice, but we only list it once. A table, it is the y values. On the graph, it is the y values. On the output, it is the y values. If you are given a relation, how do you tell whether it is a function? You tell if every input has exactly one output. Here, -2 has exactly one output, which is -1. -1 has exactly one output, what is 0. 3 has exactly one output, which is 0. And 6 has exactly one output, which is 4. Notice that -1 and 3 each have the same output, but they have only one output. So the relation is a function because each input is mapped onto only one output. The second example that we are given here, -2 has only one output, which is -2. 1 has only one output, which is 0. But notice that 2 has two outputs. 2 can go to 2, or 2 can be mapped onto 3. So in example B, the relation is not a function because the input 2 is mapped onto 2 and 3. Both of these pictures represent functions. See if you can take a moment to represent the domain and range of each of the functions. The domain for A is the set of all x's such that 0 is less than or equal to x, which is less than or equal to 6. That means that the inputs can be any number between 0 and 6. The range is going to be the set of all y's such that 0 is less than or equal to y, which is less than or equal to 6. The domain for B is the set of all real numbers. Notice that x can be negative, x can be 0, x can be positive. So we say that the domain is all real numbers, which is a double-lined R. The range is going to be all numbers greater than or equal to 0. So we would say y such that y is greater than or equal to 0.